This is lecture 11, Warehouse Space and Layout Planning, Part 1 for IE 4355 Facilities Planning. The material that is discussed in this lecture is also available in Chapter 11 of your textbook. The title of the chapter is Warehouse Operations. As always, we start our lecture with the course objectives. And as we've been doing for the last couple of lectures, our objective or the objective for this class that is mostly related to the topic that we're discussing is to develop an understanding of the principles of facilities location, layout, and material handling systems, and to practice designing facilities. So this objective is very closely related to the material that we're going to cover today, in which we're going to be discussing how to design certain aspects of the warehouse. So the agenda for this lecture is listed in this slide. We're going to start with the introduction, and then we're going to discuss the missions of warehouse. We're also going to discuss the functions in the warehouse, the receiving and shipping operations, and the storage operations, including the storage space planning, or how to plan for the space needed for the warehouse and how to use the space in the warehouse. So the learning objectives for this particular lecture is to learn warehouse operation improvement through the application of best practice procedures and available material handling systems for warehousing operations. So let's jump into the introduction. A renewed emphasis on the supply chain and customer satisfaction has increased the number of and variety of value-added services in the warehouse. The extra services may include kitting, special packaging, and label application. In a warehouse, resources include people, equipment, and space. Unfortunately, such resources are often difficult to obtain and retain/maintain. So the planning and management of today's warehousing operations are very challenging. And you have seen that now with the boom in companies such as Amazon, warehousing and warehouses are becoming a very important aspect of doing business. Same thing for UPS, HEB, Walmart, especially during the COVID-19 pandemic. You have seen how all services have moved to the online version, or most of the businesses have moved to the online environment, which involve most of the time the shipping of the products, the delivery of the products, and most of the time there's several structures within the supply chain, like warehouses, that are relevant and that they must be used efficiently in order to operate correctly. So what are the missions of warehouse? The warehouse plays a critical role in supporting a company's supply chain success. The mission of a warehouse is to effectively ship products in any configuration to the next step in the supply chain without damaging or altering the product's basic form. All warehousing opportunities, including order picking, cross-docking, productivity, space utilization, and value-added services, allows the warehouse to process and ship orders more effectively. So what are the missions of a warehouse? First, improving order picking operations. The supply chain requirements today are driving warehousing operations to develop better order picking solutions. So again, going back to the example of Amazon, every order from every customer is different. And you have a wide variety of products that can be stored in a warehouse. So the order picking operation has to be very efficient, so you can put together those orders and you can ship them on time. So improving order picking operation is one of the most important missions of a warehouse. Utilizing cross-docking. So the idea of cross-docking is to have a in-between a structure between the customer and the warehouse, in which you can sort items at a specific point that are coming from different warehouses. Let's say you order something, or you order 2 items as a customer, but those 2 items are not located in the same warehouse. So instead of shipping that item from warehouse to warehouse, what usually happens is that there's a cross-docking structure in which the shipments can go to the cross-dock, and then they can be put together in the same order and then shipped to the final destination, which is the customer. So it's, again, it in between structure that is efficient in the sense of not having to exchange products between warehouses. You can find a middle point to locate that cross-dock, and then use that cross-dock to put together packages that require items from different warehouses. So the receiver typically requests that the cross-dock goods be sorted and pre-labeled. So the picture right here is showing the idea. So as you can see, the suppliers have different colors, are represented by different colors. So those are the items that are coming from the different suppliers. And then the customers are requiring different items from different suppliers. So what's going to happen is the suppliers are sending all those items to the cross-dock facility, and they're getting sorted, and then they're going to be sent to the final customer destination. So before cross-docking, you see every supplier will have to go all the way to the customer, and they will have to travel to each customer. So let's say Blue will have to go to customer 1, 2, and 3. With a cross-dock, you are basically saving time, because you don't have to send that supplier to each one of the customers. You just send the supplier to the cross-dock, and then the delivery is a separate operation that will happen from this point to the customer. Number 3, increasing productivity. Maximize the effective use of space, equipment, and labor. So again, even if you have a very large warehouse, you know that the space utilization is important, because there's a cost associated with the space. So you want to make sure that that every time you are using or locating an item in that limited space, that it's used wisely. So increasing productivity means maximizing the effective use of space, equipment, and labor. Utilization, or utilizing space. The old rule of thumb has always been that when a warehouse is more than 80% full, more space is needed. Okay, so if you have 80% to your capacity, then that means that you're running out of capacity, and you have to move some of that product or supplies out of your warehouse, or you have to find a way to expand the space. Increasing value-added services. Warehouses' role has extended to include services that facilitate more efficient operation in the receiving warehouse, and therefore that benefit the customer. So some of these value-added services include faster shipping, or if you want to wrap the product as a gift, or if you provide some type of additional service connected to the product that you're delivering. So those are value-added services. Also for the returns, so if you take care of the returns, so those services are also part of value-added services that are increasing. So the old definition of a warehouse as just a place to store, reconfigure, and shorten lead times have become much more complex and technology driven. So now they have all these links, all those and add-on services attached to the operation of the warehouse, different type of products, customized products, and so on. So there's opportunities for improvement. There's always opportunities for becoming more efficient. And those are the things that we are going to be studying. So what are the functions in the warehouse? There are many activities that occur as part of the process of getting material into and out of the warehouse. And there are illustrated in this figure number 2, include the typical warehouse functions and flows. So as you would imagine, there's some receiving and some shipping, but there's a direct way to reserve. So not the items will remain in the warehouse. Research, storage, and pallet picking, and direct put away to primary, in which you're probably going to move this faster. So case picking is going to occur in this area. If you need to replenishment, then you have to pull from this area. But these are the area. This is the area where most of the items are going to. The items that are active in terms of being requested, let's say the most, they're going to be part of that area. And then you have some of the individual items that need to be split into individual items, and then accumulation, sortation, and packaging, and then shipping. So these are some of the additional functions in addition to the traditional receiving and shipping. So functions in the warehouse, receiving is the collection of activities involved in the orderly receipt of all materials coming into the warehouse, assuring that the quality and quantity of such materials are as ordered, and dispersing materials to storage or to the other organizational functions that need them. Number 2 is the inspection and quality control, are an extension of the receiving process and are done when suppliers are inconsistent in quality. So it's important. You want to receive the items at the time of receiving those items in the receiving dock. You want to make sure that those are to specification, because you are assuming the responsibility once are they part of your warehouse. So you are going to be supplying something that is probably defective to your customers, then that will create additional trouble into your facility in the means of getting returns or maybe getting the dissatisfaction of your customers. Repackaging is performed in a warehouse when products are received in bulk from a supplier and subsequently packaged singly in merchandisable quantities or in combination with other parts to form kits or assortments. Number 4, a put away is the act of placing merchandise in storage. It includes material handling and placement. Number 5, storage is the physical containment of merchandise while it is awaiting a demand. So if it's not going to be moved because customers are, or you don't have enough demand, then you put them into the storage area. Order picking is the process of removing items from storage to meet the specific demand. So again, looking back into Amazon, you have to put together all these boxes for your customers. You have multiple items. Are you going to put them all in the same box, or are you going to ship them together? Or if you're going to put them all together, then you have to go and find those items. This also happens to HEB. Like for instance, if you go to warehouse in San Marcos for HEB, the customers for this warehouse are the supermarkets. So they will get these orders from the supermarkets telling them like, okay, I'm low in, let's say, a paper towel, or I'm low in the produce, or I'm low in, I don't know, soap. So I need this many boxes. So they will go and do the order picking for the supermarket, and they will put together all these pallets with all the items that are needed by the supermarket, and then they will ship those. So the order picking is not only for a customer, but it could be also for a facility. Sortation of batch picks into individual orders and accumulation of distributed picks into orders must be done when an order has more than one item and the accumulation is not done as the picks are made. So if you're, for example, doing the order picking for multiple customers at the same time, you're taking all those items together, and then you have to go sortate them to put together the orders for the individuals. Checking, packing and shipping, checking orders for completeness and loading the trucks. Cross-docking, inbound receipt from the receiving dock directly to the shipping dock. And replenishing is primarily picking locations from reserved storage locations. So let's talk about receiving and shipping operations. The key decision in designing the receiving and shipping functions is whether to centralize the two functions. As expected in this figure number 3, the location of receiving and shipping depends on the access to the transportation facilities. So there's, for example, if you have access to a highway and railroad here, look at the top. This is the access that you have for transportation. Then you want to put together, or you want to put your receiving and shipping functions next to that area. Whereas in this second example, or this second line, you have access to the street in this area and then also this area, so that gives you more flexibility. So if you want to split the shipping and receiving, you can also do that. And in this case, you basically in this you have located in a corner. But if you're not located in a corner, and you have access to opposite side of the building, have access to the street or the highway or the railroad, then you also have flexibility in terms of putting those shipping and receiving in a separate locations, or separate across the location of the other. The following principles serve as guidelines for streamlining receiving operations. They are intended to simplify the flow of material through the receiving process and to ensure the minimum work is required. Number 1 is done receive. For some materials, the best receiving is no receiving. Often, drop shipping, having the vendor ship to the customer directly, can save the time and labor associated with receiving and shipping. Number 2, pre-receive. The rationale for staging at the receiving dock. The most time and space intensive activity in the receiving function is often the need to hold the material for location assignment, product identification, and so on. Number 3, cross-dockable material. Since the ultimate objective of the receiving activity is to prepare material for the shipment of orders, the fastest, more productive receiving process is cross-docking. The simplest kind of cross-docking activity is one in which an entire inbound load is sorted and then reloaded onto one or more outbound vehicles. So the idea again of the cross-dock is that you don't store. You're basically getting items, you're sorting them, and then you're shipping them. So that's the ideal operation of a warehouse, if you want to see it that way. If you have to store them, there's some additional activities that are associated with that process, and those are not value-added activities. So that's going to cost you, like storing, order picking, And also there's time associated with those activities. Complete all necessary steps for efficient load decomposition and movement at receiving. The most time we will ever have available to prepare a product for shipping is at receiving. Number 5 is sort inbound materials for efficient put away. Inbound materials can be sorted for put away by warehouse zone and by location sequence. Number 6 is to balance the use of resources at receiving by scheduling carriers and shifting time-consuming receipts to off-peak hours. So if you have a lot of activity happening in your warehouse between, I don't know, in the afternoon, and you know that you are about to receive an order from a carrier that, for example, it will occupy your dock for a long period of time, then you don't want that. You want to make sure that those operations and those receiving activities are happening out of the peak hours for your warehouse operations. Minimize or eliminate walking by flowing inbound material past workstations. Bring the stock to an order picking station equipped with the aids and information to perform the necessary task. The shipping principles: select cost and space effective handling units. So for loose cases, the options for unitizing loose cases include wood, disposable, returnable, and rentable pallets, plastic, metal, and nestable pallets. For loose items, the option for unitizing loose items include totes and cardboard containers. Number 2 is to minimize the product damage. Number 3, it should be 3, sorry. Should be 4, should be 5. So number 3 is the use of storage rack to minimize floor space requirement for shipping and staging. Number 4 is route on-site drivers through the site and minimize paperwork and time. And number 5 is small parcel shipping. Let's talk about storage operations. The objective of storage and warehousing functions is either to maximize resource utilization while satisfying customer requirements, or to maximize customer satisfaction subject to a resource constraint. Storage and warehousing resources are space, equipment, and personnel. In designing storage and warehousing systems, it is desirable to maximize space utilization, equipment utilization, labor utilization, material accessibility, and material protection. Now let's talk about storage space planning. A chart that can be used to facilitate the calculation of space requirements for storage and warehousing is the storage analysis chart. So as you can see here, the information includes the date, the type of product, is raw materials, plant supplies, the company, who was the author or who prepared the form. And then we have information here in terms of the description for the products, the type. So are these bundles, racks, cartons, drums, pallets? The capacity for those, how many are in those type of bundles? The size, the weight, the maximum, the average, and the plan. The method for transporting, the specs, the area, and the ceiling height required. There are two major material storage philosophies. The first one is called the fixed or assigned location storage. The second one is the random or floating location storage. In the fixed location storage, each individual stock keeping unit, or SKU, is stored in a specific location, and no other SKU may be stored there, even though the location might be empty. With random location storage, any SKU may be assigned to any available storage location. An SKU is stored in location A 1 month might be stored in location B the following month, and a different SKU stored in location A. So random location, basically no assignment, fixed location, fixed assignment. The amount of space planned for an SKU is directly related to the method of assigning space. If fixed location storage is used, then a given SKU must be assigned sufficient space to store the maximum amount that will ever be on hand. And that's very important. So the maximum amount that will ever be on hand. For random location storage, the quantity of item on hand at any time be the average amount of each SKU. So in the fixed location, you're basically making sure that if you get a large order, that you are able to put it in that fixed location. For random location storage, you have more flexibility. So what that means is, since you don't have a fixed location for that product, you can easily expand if needed. So when the inventory level of one item is above the average, another item will likely be below the average. The sum of the two items will be close to the average. If a large safety stock of SKUs is maintained, then the quantity of items on hand at any time will be the safety stock plus 1/2 the maximum replacement quantity of each individual SKU. So let's talk about determining the storage space requirement in number of loads. So these will use some computations that you're familiar with. So in this problem, we have a manufacturing firm. The average daily withdrawals rate for product A is 20 cartons per day. The safety stock is 5 days, and the order lead time is 10 days. And the order quantity is 45 days. The question is, what are the maximum and average quantities of unit loads to be stored? So in order to determine that quantity, we have to compute two other parameters first. First one is called the reorder point. Which is going to be equal to the safety stock in days times the demand per day plus the lead time in days times the demand per day. So this is going to be equal to, for this problem, 5 days times 20 cartons per day plus 10 days times 20 cartons per day. And this is going to be equal to 300 cartons. The second parameter that we have to compute is the maximum quantity to be stored. So the maximum quantity to be stored is going to be equal to the safety stock plus the order quantity. So the safety stock is going to be equal to 100 cartons plus the order quantity, which is 45 days times 20 cartons per day. So this is equal to 1,000 cartons. Then finally, we have the average quantity to be stored. And that's going to be equal to 1/2 the order quantity plus the safety stock. So that's equal to 1/2 times 900 plus 100. And that is going to be equal to 500 cartons. So maximum and average quantities of units to be stored. They are computed here. Maximum is going to be 1,000 cartons. The average quantity we store is 500 cartons. So I'm going to stop here. In the next video, the next lecture, we are going to continue our discussion on warehousing. And we're going to look at differences between randomized versus dedicated storage. And we're going to look at some examples for you to understand the difference. So that's the next video. Thank you.